This week in lab, we worked with the spectrophotometer. And before we had to work with the spectrophotometer, we had to get dilutions. And this is us taking the dilutions. You can see here we're measuring the volume using a pipette, and we're doing it by looking at the meniscus. The meniscus is curved because of the water bonding. We use this method for every dilution that we made during this lab. We made a total of 4 dilutions. Each dilution we had to insert into a curvette. For this, we used the smaller plastic pipettes, which are less accurate. We pipetted them into the little curvettes up to a line that is displayed to show where you should stop. We did the same thing with all of the solutions that we had from the dilutions, and then the stock solution and the blank that we needed, which is just NaOH and water. Then we moved to the next room to use the spectrophotometer. We cleaned the curvettes before inserting them into the spectrophotometer, so the sides that are exposed won't have anything blocking or interfering with the absorbance. Here we are wiping the curvette again for our stock solution and inserting it into the spectrophotometer. We are going to measure this absorbance across all wavelengths to see at which wavelength does the most absorbance happen, so that we can run the later dilutions against the peak wavelengths to give us the most accurate representation of absorbance against the concentration, so we can know the relationship. As we are recording the rest of these dilutions, we will put it in a table of X and Y values, Y being absorbance and X being concentration. Now we are getting the rest of the dilutions in the spectrophotometer to see the correlation and find the slope to later use in the Beer-Lambert law. But we are doing this by using the peak, as earlier mentioned. Peak is lambda max, and the lambda max is the maximum absorbance. All of the absorbances that we have found so far are recorded into the chart. The chart will be used to find slope and fill in some of the blanks in the Beer-Lambert's law. The Beer-Lambert's law is A equals ELC. The A is the unknown absorption that we are trying to find. E is the slope, which we will find using the change in Y over the change in X, which is also found in the chart. We will use a concentration that we already know because we are given it, and then L is already given as 1, so it will not be a factor in our calculations.